Hey guys, today we are going to look at 1.2, which is going to talk about some more angles, specifically angle relationships. And then we're also going to talk about some triangle things and some similar triangles. So first thing is vertical angles. So vertical angles can be two angles that are kind of on top of each other like this, or it can be two angles that are across from each other sideways like this. And if they are vertical angles, they have the equal measures. So if one of them is 77 degrees, then the other one is also 77 degrees. Vertical angles have equal measure. Then the next angle relationships that we're going to look at have to do with parallel lines and parallel lines being cut by a transversal. So over here is what that picture looks like. Parallel lines are lines that lie in the same plane and do not intersect. When a line Q does intersect two parallel lines, we call it a transversal. And do be careful that you are not just assuming that two lines are parallel lines. You do need to be told that they are parallel lines. Remember that pictures can sometimes be deceiving. So don't just assume something based off of the way the picture looks. You need to make sure that you can see it labeled as parallel, or that it says somewhere in the question or the directions or something like that, that the two lines are parallel. So the relationships with our parallel lines, the first ones are alternate interior angles. So examples of those would be 3 and 6, angle 3 and angle 6. Another example would be angle 4 and angle 5. So alternate interior angles are angles that are on alternate sides of the transversal, so opposite sides of the transversal. And then interior means that they're on the inside of the parallel lines, the interior of the parallel lines. If they are alternate interior angles, then that means that the angle measures are equal. They are the same degrees. So 3 and 6 would have the same degree measure, 4 and 5 would have the same degree measure. Alternate exterior angles would be 1 and 8. So angle 1 and angle 8, or 2 and 7. Angle 2 and angle 7. So same thing, alternate means on opposite sides of the transversal, but exterior now means they're on the outside of the parallel lines, the exterior of the parallel lines. But they have the same relationship. It means that the angle measures are equal. So angle 1 is the same size as angle 8, and angle 2 is the same size as angle 7. The next relationship is interior angles on the same side of the transversal. So interior means that they're still inside the parallel lines, but now they're just on the same side of the transversal. So angle 3 and 5 would be an example of interior angles on the same side of the transversal. And our other example in this picture would be 4 and 6. Angle 4 and angle 6. Now these have a slightly different relationship. The angle 3 and angle 5, or angle 4 and angle 6, they would add up to 180 degrees, which means they are supplementary angles. And then the last angle relationship that we're going to look at in our table are corresponding angles. And we actually have 4 sets of corresponding angles in our picture here. First would be 1 and 5. So corresponding angles means that they're in the same spots from one parallel line to the other parallel line. So angle 1 and angle 5. Okay, another example would be angle 3 and 7. Another example would be 2 and 6, angle 2 and angle 6. And then our last example would be angle 4 and angle 8. So the corresponding angles are in the same spot from one parallel line, so M, to the other parallel line, N, or the other way around. And those angles are the same size. So 1 is the same size as 5, 2 is the same size as 6, 3 is the same size as 7, and 4 is the same size as 8. Now, these are 4 different relationships that show up in this picture, this diagram of the 8 different angles. But these are not the only relationships that are present. There are a lot of other relationships that are present. So just keep that in mind as you go through these problems. There are sets of vertical angles that are happening here in this. We talked about interior angles on the same side of transversal, but what about exterior angles on the same side of transversal? What do you think would happen with that relationship? There's a lot of different relationships than just these 4 that were in our table. So let's kind of look at how we could use these relationships to help us solve for some angle measures. Because once you know one of the angle measures for one of those 8 angles, you can find all the other ones using some of these relationships. So we've got a picture here, a nice diagram here. It says find the measures of angles 1, 2, 3, and 4, given that lines M and N are parallel. So it does tell us our lines are parallel in the directions for the example, so all of our relationships are going to work here. We don't actually know what any of the angle measures are, but it does give us some information about angle 1 and angle 4. It says that angle 1 up here is 3x plus 2, and angle 4 down here is 5x minus 40. And one of the angle relationships that we talked about in our table does help us here because 1 and 4 are alternate exterior angles. And if we look in our table, alternate exterior angles means that the angle measures are equal. So what that means is that angle 1 has to equal angle 4. So I can say that 3x plus 2 has to equal 5x minus 40. And I can figure out what x is from that equation, which means I can then figure out what those angle measures are and figure out what all the other angle measures are. So I would start by subtracting 3x from both sides. So 2 is going to equal 2x minus 40. And then I can add 40 to both sides. So 42 is equal to 2x. And then divide both sides by 2. So x is going to equal 21. So now that I know that x equals 21, I can plug that in either to the 3x plus 2 or the 5x plus, or sorry, 5x minus 40. I don't have to plug it into both of them. I just need to plug it into one of them because I already know that they're the same thing. However, if I plug it into both of them, that would help me double check and make sure that I did my math right. Because if I don't get that they're the same thing, then that means I did something wrong. So let's plug it into 3x plus 2. If I do 3 times 21 plus 2, 3 times 21 is 63 plus 2 gives me 65. So I can say that angle 1 and angle 4 are both equal to 65 degrees. Down here, 5 times 21 is, what is 5 times 21? 105, yeah, 105, sorry. Mental math was a little rusty there. And then when I subtract 40, that also gets me 65, yes. So there we go. Checked, and we're good to go. From here, there's a couple different ways that I could figure out what my other angles are. Trying to figure out what 2 is or trying to figure out what 3 is. I can look, let's start with 3. If I look at 3, 3 and 4 are corresponding angles. And I know that corresponding angles have the same angle measures. So that means that angle 3 is equal to 65 degrees as well. I also could have noticed that angle 1 and angle 3 are vertical angles, so they have to be the same as well. Then my last one that I need to figure out is angle 2. And I can look at the relationship between 1 and 2 or 2 and 3. Either way, I'm going to figure out that that is a supplementary angle relationship. And I'm going to know that 180 minus 65 is going to get me whatever that angle 2 is. So 180 minus 65 is 115. So angle 2 is going to be 115 degrees. And there are our 4 angles that we needed. Okay, so that was some angle relationships, working with angles. Let's switch gears a little bit and let's talk about some triangles. So just a quick refresher from geometry. I know it's been a little bit. When we're talking about triangles, we can label triangles based off of the angles in the triangle or based off of the sides in the triangle. So if I'm looking at angles, if all the angles are acute angles, then it's going to be an acute triangle. And remember, an acute angle is any angle that's less than 90 degrees. If I have one right angle, then it's going to be a right triangle. And our right angles are represented by that nice little box right there telling us it's a 90-degree angle. And if I have one obtuse angle, it's an obtuse triangle. And obtuse angles are greater than 90 degrees. Okay, then if I label based off of the sides, if all the sides are equal, that's an equilateral triangle. That one's kind of easy to remember because equilateral. If two sides are equal, then that means it's an isosceles triangle. And if none of the sides are equal, then it's a scalene triangle. Okay, then another thing that's helpful to remember about triangles is our conditions for triangles to be similar triangles. So if I want to say that triangle ABC is similar to triangle DEF, then for it to be similar, the corresponding angles have to have the exact same measures. So like A would have to be the same as D, B the same as E, and C the same as F. But when I'm talking about the corresponding sides just must be proportional. So that means the ratio of their corresponding sides has to be equal. So we'll kind of look at that a little bit more on the next page, but that means that if I have 3 different sides and I take like the bottom of one triangle compared to the bottom of the other triangle, the ratio between those two sides has to be the same as like the left side of one triangle to the left side of the other triangle, the ratio between those two sides, and the right side compared to the right side of the other triangle. Before we get into that similar triangle though, a couple other things that we need to remember about triangles. Example 2 says the measures of two of the angles of a triangle are 48 degrees and 61 degrees. Find the measure of the third angle. So remember, all of the angles in a triangle add up to 180 degrees. So if I'm trying to find this missing x right here, I can do 180 minus 48 minus 61 to get that it's 71. So x would be 71 degrees. And also using that and some of our other angle relationships that we talked about, we can solve problems that look like example 3 right here. So to find the measure of each marked angle, I've got this angle up here in the top of my triangle, that's 5x minus 111. I've got this angle over here in the bottom left of my triangle, that's x plus 11. But the other angle that's marked is this one that's outside of my triangle, that's 5x minus 64. Now I know all the triangles angle needs to add up to 180, but that 5x minus 64 is outside the triangle, not inside the triangle. So it's like this purple one is missing that I don't know what it is. But if I look, that purple one and the one outside that I have marked in blue, those also have a specific relationship as well. They make a straight line, which means that those are supplementary angles, which means they also need to add up to 180. So if the two pink ones plus the purple one is 180, and the purple plus the blue one is 180, then I can make the two pink ones, when I add them together, equal to the blue one because of those relationships both equaling 180, the angles in the triangle and the supplementary angles. So what that means is that 5x minus 111 plus x plus 11 has to equal 5x minus 64. Okay, I can solve this. I can combine like terms over here. So 5x plus x is going to give me 6x. Negative 111 plus 11 is negative 100. I'm going to subtract 5x from both sides. So x minus 100 equals negative 64. And I'm going to add 100 to both sides. So x equals 36. And then don't forget, we need to make sure that we're actually reading our directions. It didn't just tell us to find x. We need to also plug it back in and actually find the measure of each of the marked angles. If I plug it into the top one, that would be 5 times 36 minus 111, which should give us 69 degrees. If I plug it in over here to the x plus 11, 36 plus 11 is going to give us 47 degrees. And our outside angle over here, 5 times 36 minus 64, that one will give us 116 degrees. Okay, so we can use things we know about triangles and things we know about our angles and our angle relationships to help us solve different types of problems. Last thing we're going to look at in the set of notes is our similar triangles. So example 4 says, in the figure, these two triangles are similar. Find the measures of angle B and angle C. When you're looking at similar triangles, you can look at how the triangles are marked or how they're labeled to help you kind of figure out which parts are the similar parts. So if I'm looking right here at A, highlighter, A, it's got one tick mark, one angle measure mark, and N over here also has one tick mark, one angle measure mark. So 1 and 1. They're also both labeled as 45 degrees. So those go together. Those are the corresponding angles from one triangle to the other triangle. If I'm looking at B, B has 1, 2, 3 tick marks. So over here, that's going to go with M because M also has 1, 2, 3 tick marks. So if M is labeled as 31 degrees, then that means B should be 31 degrees. And then C has 2 tick marks and P has 2 tick marks. 1, 2. Let's draw that a little nicer. 1, 2. So if P is labeled 104, then C should also be 104 degrees. I know that this one, it was pretty easy to kind of see based off of how the triangles look, where the corresponding angles went, but do be careful because remember your drawings can sometimes be deceiving. So don't just go based off of how they look. You need to see how things are labeled or how they tell you how things are. So in the next one, let's look at our corresponding sides. Instead of them being exactly the same, this is where we have to set up our ratios. So I'm going to look at my first side over here from A to C. That's from the angle with 1 tick mark to the angles with 2 tick marks. So same thing over here, D to E. Those are the corresponding sides because they go from the corresponding angles to the corresponding angles. So when I set up my ratio, I can set up the 8 and the 16 and the fraction together because those are the corresponding sides. So I would do 8 over 16. Then if I'm trying to find, let's start with the bottom and let's say that's x. That one goes from 1 tick mark to 3 tick marks. So it's going to go with 1 tick mark to 3 tick marks, which would be our 24. So that fraction is going to be x over 24. When you're setting up your ratios, it doesn't really matter which triangle you pick on to be on top versus on bottom, but whatever one you start with on top, like in my pink fraction, I've got to be consistent and that's got to be the same one that's on top for the second fraction. Then from here, to solve for x, all I need to do is just multiply both sides by 24. So 24 times 8 over 16 would get me down to x equals 12. So this side length would be 12. You also can just look at that picture and kind of tell that 16, 8 is half of 16, 24, half of that would be 12. So sometimes it's really easy to tell just by looking at the pictures, but when it's not, that's when you would set up your ratio and your proportions. So for this other side, let's call it y. That's going to match up with my side over here that's 32. So I can set up a similar proportion. I can do 8 over 16 needs to equal y over 32. And I can do the same thing. I can multiply both sides by 32. And I get that y is 16. So that missing side is 16. Ooh. Okay. Once again, you also could have looked and half of 32 is 16. Okay, so let's do another one. This one's a word problem, a real world example. It says workers must measure the height of a building flagpole. They find that at the instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole. So if we're looking, we know that the building in the ground and the flagpole in the ground make right angles, and those are labeled really nicely for us on our triangle. We also know that the sun is going to hit them at the same angle, so those two angles in the top are going to be the same, which also tells us that these angles down here are going to be the same, and we've got our similar triangles. So we can set up a ratio. Let's say the flagpole is x meters high, so from here we need to just set up our ratio. I'm going to start with the x over the 10. So I'm looking at this side over this side. So then my other fraction, I need to start with the 27 because I started with x and it's going to go over the 18. So equals 27 over 18. From here, I can just multiply both sides by 10. And I get that x is equal to 27 over 18 times 10 gives me 15 meters. You can plug that into your calculator. And there we go. You also could have noticed that 27 over 18 does simplify down to 3/2. And then multiply it by 10. Okay, so that's it for this set of notes. If you have any questions, let me know. Make sure you get started on your assignment that goes with this, and you guys have a good day.